In this video, I'll show you how to configure MPLS VPNv4 on iOS XR based nodes. Let's get to it. So in this topology, I have two CE nodes, CE1 and CE2. This will be running on VRFA. And I have PE1 and PE2. These are two XR nodes. And the P-core nodes here in the middle, that's the Cisco iOS. And then I'm using a root reflector, which is also running iOS XR. The service provider in this case spans P1, P2, the P-core and root reflector are running OSPF area 0. So the tasks that we have to carry out to enable connectivity between CE1 and CE2 are first of all to configure IGP in the backbone. So that will be the first starting point. We make sure that OSPF is enabled and working for PE1, PE2, the P node and the root reflector. The next thing will be to configure MPLS LDP. So this one will be between the P nodes, P1, P2 and the P-core. There is no need to have MPLS LDP running between the root reflector and the rest of the network. The next step will be to define the VRF on the P nodes. So we will be defining and configuring VRFA on PE1 and PE2. The next step will be to configure VPNv4 peering. So there's two ways this can be done. Either we configure a peering session between P1 and P2 directly. Now this doesn't scale when you have more than 2 or 3 or 4 PEs. The best way to do it will be to configure this peering using a root reflector. And the final step will be to configure the routing between the P and the C nodes. So in this case, we're going to go for BGP between the P1 C1, P2 C2. So let's start with a blank canvas, and that would be P1. On the remaining nodes, so that would be P2 and the P nodes, iOS-based P node, root reflector, I have already configured IGP and MPLS LDP and so forth. So we will use P1 as your template, if you like. So let's start by configuring the interfaces, starting by loopback 0, IPv4 address. Here you have the choice of either going for the classic way of defining your whole subnet mask or simply configuring a /32. And then I jump to the interface facing the P node, IPv4 address. So this would be 10.1.3.1. Same issue here, or same stunt. And I will open up my interface. And then I commit. So the next thing will be to configure my IGP, so that would be the OSPF process. In iOS XR, we're using naming for processes. I always like to define my router ID, whether it's for a BGP or OSPF. So whenever it's an option, I will define my router ID. And then you have to define which address family you're configuring OSPF for. So in our case, it would be address family IPv4 unicast. And then we are under area 0. And here I add the interfaces that I would like to have running OSPF under area 0. First interface is the uplink towards the P node. And then the next one would be interface loopback 0. Now I'll show you something that I do quite a lot in production. This command is quite handy, so it's show commit changes diff. So this shows me the part that I'm about to commit before I commit it. So you can see that it's under OSPF lab 1. I'll define the router ID, address family, area 0 and the two interfaces. You see the plus means that I am adding this configuration. In some cases, when you're adding some configuration to your production node, you also subtracting, you're removing something else. So this option here, the show commit changes diff, will show you if you are about to impact something major in your configuration. It gives you that, extra safety before you commit. So this I'm happy with. I'll just go ahead and commit. Show OSPF neighbor, hopefully, yep, now we have it, and show root OSPF. So note that I'm not doing show IP root. On iOS XR, you just do show root OSPF or whatever routing protocol you're looking for. Here, I want to make sure that I have all the loopback addresses of the nodes in the backbone. So I have the 222, 3, 4, and some link addresses. So that looks good for the time being. The next task in our list is to configure MPLS LDP. Same here, I have already configured MPLS LDP on the P node, which is iOS based, and also on PE2. So this will be your template on how to configure MPLS LDP on iOS XR. It's actually a very simple configuration, MPLS LDP. And as I mentioned earlier, I like to define or hardcode my router ID. And then the only interface where I would like to run MPLS is actually the interface facing the uplink, so towards the P node. I don't need to have MPLS running between the P1 and CE1, not in this particular case. And then I'll commit. And then let's go through the validation. Here we go, you just needed a bit of time. So I have my neighbor, which is, you can see here. And I'll check my forwarding table. I'll also see my prefixes and the label switching happening here or wherever it needs to be popped. So far so good. Our next step is to configure or define the VRF. So in this case, I've chosen VRFA, which would be configured on both P1 and P2 only. So I define my VRFA, address family, IPv4 unicast. And then this is very similar to iOS way of doing things. And my root targets here. So I will import and I will also export. So now that I have defined my VRF, I need to apply it on the interface facing the C node. So that would be gigabit VRFA, and then add my IP address. If you're not familiar with the /31, is essentially 255, 255, 255, 254, and it gives you two hosts. So there's no wastage, if you like, of IP addresses. I have applied the same configuration on PE2. Let me just make sure that I can ping the CE. Now we have a point-to-point link between P1 and CE1. So let me ping myself first. Yep, I can ping. And the next host will be 1. And I can reach CE1. If I hop into PE2, You can see my configuration here is exactly the same. So I have VRFA, this is facing CE2, and I've got a different IP address, 192.168.1.0 and /31. Let me ping the other end. So that would be a .1, and I can ping it. So to recap, we have configured our IP addresses, we configured our RGP in the backbone, we configured MPLS LDP, and we also defined our VRF, in this case VRFA, on PE1 and PE2. The next step for us is to start configuring BGP VPN4 between PE1 and PE2. Now, as I mentioned earlier, there's two options. You can either configure a direct peering between P1 and P2. The preferred and scalable method is to use a route reflector. So this is where we're going to start. So I'll hop into my route reflector here. And I'm using the classic BGP AS100. I configure my router ID, which is essentially my loopback address for the route reflector. And I initialize my address family. So this you have to do at the start. It could be address family IPv4 unicast or v6, depending on what sessions you're going to configure later on. In my case here, we're configuring VPNv4, so this is the only address family that I'm going to add for the time being. So I'll exit from here. If you watched one of my previous videos about how to save time or how to configure BGP the smart way, you will see that I like to use neighbor groups. So here we're just going to use that method to actually simplify our configuration, and I will leave a link for the specific configuration of neighbor groups in the description. So neighbor group, I'll just define it initially, and I can call it anything I want. I will call it lab1 or peers, whatever you want. Let's be more specific. Clients. So here I'm defining a neighbor group that will be applied to my clients, my route reflector clients. So what is common for all these route reflector clients is that they have the same AS number. The update source is loopback 0. Address family is VPNv4 unicast. And they are route reflector clients. So this I will commit. Now that I have defined the neighbor group, I can start working with the action neighbors or the peering sessions. So starting with my PE1, I will use or reference the neighbor group that I have created, and this will inherit the configuration that I have used to define the neighbor groups initially. So to avoid any typos, I'll just copy and paste. And I'll do the same for PE2. And I commit. So this actually makes the configuration very simple and scalable. I don't have to repeat the same elements of the configuration. Let me just show you the router BGP. So what we have defined is obviously the process for the router BGP, the router ID, address family VPNv4, because that's what we're going to use next. And then we defined a neighbor group. We called it lab1 clients. And all the common parameters, if you like. So the remote AS will be 100. The update source is loopback 0, VPNv4, and they are route reflector clients. Then I select or I configure my neighbor, and I use the parameters that are defined previously. So if I have 150 peering sessions, I don't have to write this 150 times. I will simply refer to the neighbor group. Now let's hop into PE1 and configure VPNv4 here as well. Configure my router ID, so that would be address family VPNv4 unicast. And then exits and my neighbor, which would be my root reflector in this case. Remote AS, it's an IBGP 100. Loopback 0. Address family. Unicast. So what am I adding? Router BGP 100, router ID in here, address family initialized for VPNv4, and then I'm peering with the neighbor, which is root reflector, remote AS, update source, address family. Happy to commit. I have already applied this configuration to P2. Show BGP VPNv4 unicast summary. So you can see here my session is up. I will run the same validation on the root reflector here. I can see that I've got a session up towards P1 and towards P2. On P2 you will notice that I'm receiving a prefix already, and that's because I have already applied the configuration, the P to C configuration on between P2 and C2. So we need to do the same thing between P1 and C1. So the BGP configuration on C1, which is iOS based, is pretty straightforward. I'm using AS number 65001. On C2 I'm using 65002. Router ID, and then I'm using this command here, which removes the default and allows me to use different address families. No BGP default IPv4 unicast. And then I set my neighbor. So this is my P1 IP address on gigabit 00. If I go back here, shall run. So 172.610, and this is the address that I'm peering with. And I set the remote AS as 100. And then I'm hopping to address family IPv4. And then I'm advertising this network, which is my loopback 0, and activating the neighbor. So that's my loopback 0, which I'm advertising to the VPNv4, so it becomes reachable from CE2. So this is a plain IPv4 peering session, and you can see the session is down at the moment, is idle. It's because I haven't configured anything yet on the on P1. So this will be our next configuration. So I go back into router BGP 100. And here I have to hop in to VRFA. So this is under BGP, and I will show you the final configuration afterwards. And if you remember, when we defined our VRF, we defined the root targets, but we did not define a root distinguisher like we normally do in iOS. So this is where the root distinguisher will come in. It's under the BGP process for iOS XR. This is very important. The session between P1 and C1 is actually an IPv4 unicast session. So I have to initialize the address family IPv4 unicast, else I can't have the session coming up. Neighbor 172.16. That'll be 1.1. Remote AS. And IPv4 unicast, which I have already initialized. And then here I'm just gonna kind of stop at this point. I am introducing an error or a fault, and I will show you how to fix it. This is a very important step. So what have we done here? Route to BGP, and then I'll go under the VRF that I've defined earlier. I add my route distinguisher for this VRF. I initialize the address family because this is what I'm going to use later on for my peering session. Then, as normal, I go into my neighbor. I define my neighbor, which is the next hop, that's CE1, the remote AS, and then the address family unicast. And I commit, I'm happy with this. Show BGP VRF A summary. That looks great. So here, great. I have a session established, 0 prefixes exchanged, but I have this exclamation point or mark. So this tells me that something is off. Now, there is a safety mechanism with iOS XR when you establish or you configure eBGP sessions. So when you do that, as we have done here, without any filters, the session will be established, but no prefixes will be exchanged. So this is what we have established here. It's a BGP session, an eBGP session, but we haven't added any filters. So as a precaution, it is default in iOS XR that no prefixes will be exchanged until I set some sort of equivalent of route maps. So in iOS XR, they're called RPLs. And this stands for Route Policy Language, RPL. So let's configure this RPL. Conft, and then, or just conf actually, route policy. You can call it whatever you want. I'm going to make it simple. Call my policy pass. And you have a lot of options here. Very similar to route maps, but very, very powerful also. I'm not matching any prefixes. I'm not filtering anything. Basically, I just want everything to be passed. And I add my policy. And I commit. Route policy pass. So this is essentially what we have configured. Route policy pass, just pass everything. We don't care. And then this route policy here has to be applied to the eBGP session. So just show you where it should go. So it should go under the VRF peering session and under the address family. So I'll go back in. Route to BGP 100. route policy pass. I want it to be inbound. I also want it to be outbound, so I'm able to actually pass on the prefixes that are received from PE2 and really from CE2 to PE2 and then passed on to CE1. And then I commit. And let me check again my peering session. Now I am receiving a prefix. And I should also be advertising a prefix. So I'll hop into C2. So now I can see the loopback address from C1 and the local IP address. Now let's do our test, because this is effectively what we're looking for, is whether we have reachability between C1 and C2 over the backbone. So I'm going to be pinging 20.20.20, which is my loopback 0 on C2. I'll make sure I'm sourcing from loopback 0 on C1. Great. Trace route. And here you can see the labels. Just before we finish this session, I will show you the BGP configuration on P2. Route to BGP1, router ID, address family VPNv4. We set the neighbor to the route reflector, and then we went down to the VRF itself, where we have route distinguisher, address family IPv4 in this case, and then the neighbor, which is C2. We set the remote AS as 65002, and under the address family, we have added the policy, the RPL for inbound and outbound, to allow all prefixes to be exchanged. This is the end of this video, which I hope you have found informative. If you have any questions or comments, just drop them on the section below, and thank you for watching.